March 17, 2024, Eastern Ukraine. A Russian T-90EM tank worth $4.5 million protected by reactive armor, crewed by 3 trained soldiers, advances toward Ukrainian positions. An operator 8 kilometers away puts on FPV goggles, picks up a controller, launches a drone, cost $400. Parts ordered from AliExpress, assembled in a garage, strapped with 2 kilograms of explosives. Flight time 90 seconds. The operator guides the drone through first-person view, sees exactly what the drone's camera sees, spots the tank, adjusts course, aims for the turret top, impact. The $4.5 million tank is destroyed by a $400 drone, but this single engagement is just the beginning of warfare's most dramatic economic revolution in a century. This is Iron Bullet, where we analyze the battles that change wars. FPV, first-person view, technology that started with hobbyist drone racers, quadcopters, racing through obstacle courses, competitive sport. The pilot wears goggles showing real-time video feed from drone's camera, flies as if sitting in the cockpit. Speed, precision, adrenaline, cost of entry-level FPV racing drone. $200-$500. Anyone can buy components online, assemble at home, learn to fly in weeks. Hobbyist technology, nothing military about it, until Ukraine weaponizes it. Late 2022, Ukrainian forces begin experimenting with commercial drones as weapons. Early attempts use standard quadcopters, DJI Mavic, similar consumer models. Drop small munitions, grenades, improvised explosives. Effective for harassment, not decisive. Problem: consumer drones are slow. Predictable flight paths, easy to see and hear. Russian forces develop countermeasures, electronic warfare jamming, anti-drone guns, shotguns, nets. The commercial drone threat is manageable. Then someone has different idea. What if drone doesn't drop munition? What if drone is the munition? Kamikaze drone concept isn't new. Military forces use loitering munitions, switchblade, lancet, Harop, expensive, sophisticated. Military-grade systems costing $50,000, $100,000 pluses per unit. But what if you build kamikaze drone from hobby parts? Racing quadcopter frame, commercial flight controller, FPV camera and transmitter, cheap battery. Total cost $400 to $800. Strap explosive to it. One-way mission. Pilot guides it directly into target using first-person view. No GPS needed. No complex guidance. Just human operator with joystick and video feed. Early 2023. First FPV kamikaze drone strikes documented in Ukraine. Experimental. Small scale. Uncertain effectiveness. Both sides testing the concept. And by mid-2023, thousands of FPV drones deployed monthly. Both Ukrainian and Russian forces. Industrial scale production. Garage workshops. Small companies. Even volunteer groups assembling drones. By early 2024, FPV drones caused 30-40% of armored vehicle losses on both sides, more than anti-tank missiles, more than artillery in some sectors, more than anything except possibly mines. The economics are insane. 3 questions. We'll answer them at the end. How did hobby drone technology become the most cost-effective anti-armor weapon in modern warfare? Can armored vehicles survive in an environment where $500 drones hunt $5 million tanks? And the critical one, does the FPV drone revolution make traditional military hardware obsolete? Or will countermeasures restore balance? The official narrative focuses on Ukrainian innovation and asymmetric warfare. True, but incomplete. Because the FPV drone revolution happens simultaneously on both sides, and the implications extend far beyond Ukraine. Let's examine how an FPV kamikaze drone actually works. Hardware components: frame, carbon fiber quadcopter frame. Racing drone design, cost 30 T80. Lightweight, durable enough for one flight. Motors and propellers, 4 brushless motors. $40-60 total. Propellers, 10-20. Standard hobby-grade components. Nothing special. Flight controller, electronic board that stabilizes flight. 20-50. Same component used in racing drones. Open source firmware. Fully customizable. FPV camera, analog camera transmitting real-time video. 15-30. Low resolution by modern standards, but sufficient for targeting. Video transmitter, broadcast, camera feed to operator's goggles. 20-40. Frequency ranges 1.2 GHz to 5.8 GHz depending on range requirements. Battery, LiPo battery. 15-30. Provides 5 to 15 minutes flight time depending on weight and speed. Receiver. Radio receiver for control signals. $20-30. Links to operator's controller. Total electronics, 160 to 310. Add frame, propellers, antennas, connectors, 250-450s for complete drone without payload. Payload, explosives. Typically RPG warhead, artillery submunition or custom shaped charge. Weight, 1 to 3 kilograms. Enough to penetrate tank top, armor or destroy light vehicles. Complete system cost, $400-800 per drone. Maybe $1,000 for longer range variants with better components. Operator equipment, FPV goggles, $200-600. Displays video feed from drone camera. Operator sees what drone sees. Radio controller, $50-200. Standard RC transmitter. Same type used for racing drones or RC aircraft. Total operator equipment, $250-800. Reusable. One operator can launch dozens or hundreds of drones using same goggles and controller. Training time, 2 to 4 weeks for basic proficiency. 2 to 3 months for expert level piloting. Compared to tank crew training, 6 to 12 months. Fighter pilot training, 2 to 3 years. Artillery crew training, 3 to 6 months. The barrier to entry is extraordinarily low. And that's what makes it revolutionary. Stay with me. What happens in the next section explains why traditional countermeasures fail against FPV drones. But the reason isn't what electronic warfare experts predicted. March 2023. Ukrainian forces deploy FPV kamikaze drones at scale. Russian forces respond with electronic warfare. Jamming. Same systems that worked against commercial DJI drones. Initially effective. FPV drones use radio control. Jam control frequency, drone crashes. Jam video frequency, operator loses sight. Simple countermeasure. Ukrainian operators adapt. Change frequencies. Modern FPV systems can operate on dozens of different frequencies. Russian jammers can't cover all simultaneously. Operators coordinate. If one frequency is jammed, switch to another. Russian forces upgrade jammers. Wider bandwidth. More sophisticated. Covers more frequencies simultaneously. Ukrainian operators adapt again. Analog FPV systems are more jam-resistant than digital. Analog video degrades gracefully, static and noise, but often still usable. Digital video either works or doesn't. Switch to analog systems for contested environments. Electronic warfare arms. Race accelerates. Both sides deploying jammers. Both sides developing jam-resistant drone systems. The cycle continues. But here's the key insight. Jamming has fundamental limitation. If you jam too broadly, you disrupt your own communications. Friendly drones, radio networks, coordination systems. You can't jam everything without blinding yourself. And FPV drones have inherent advantages in jamming environment. Line of sight operation. Operator is typically 5 to 15 kilometers from target. Drone flies straight path. Requires line of sight video link. But short range means strong signal. Hard to jam completely without being very close to flight path. Human guidance, no GPS needed. No complex autonomous navigation. Operator sees video feed, steers drone manually. Even if signal is degraded with static and interference, experienced operator can often maintain enough control to reach target. Disposable. Drone costs $500. If jamming causes some drones to crash before reaching targets, that's acceptable loss. Build more drones. Launch more drones. Saturation overwhelms point defenses. June 2023. Russian forces deploy Lancet loitering munitions against Ukrainian armor. Sophisticated military drone. GPS guidance, optical targeting, costs approximately $30,000 to $50,000 per unit. Effective weapon, multiple confirmed kills. Ukrainian forces deploy FPV kamikaze drones against Russian armor. Hobby-grade drone, manual guidance, costs $500 to $800 per unit. Equally effective, multiple confirmed kills. Cost comparison for achieving one armored vehicle kill. Lancet system, launch 3 to 5 drones to ensure one hit, accounting for countermeasures and misses. Cost $90,000 to $250,000 per kill. FPV system, launch 3 to 10 drones to answer one hit, accounting for operator errors, jamming, defensive fire. Cost $1 to $500, $8,000 per kill. FPV system is 10 to 50x more cost effective than military grade loitering munition against $3 to $5 million tank. Return on investment is $500.1 to $1,000. 1. The economics break every military procurement assumption. This is iron bullet. Real tactics. Real consequences. How do you defend against FPV kamikaze drones? Question that military forces worldwide are desperately trying to answer. Traditional air defense, designed for aircraft and missiles. Radar-guided, expensive missiles. A $3 million Patriot missile intercepting a $500 drone is economic disaster. Can't afford to defend this way. Close-in weapon systems, Phalanx, CIWS, Panzer, Gepard. Designed for close-range air defense. Can shoot down drones. But FPV drones are small, fast, maneuverable. Hard targets. And CIWS systems cost millions. Can't put one on every vehicle. Electronic warfare, jamming, discussed earlier. Partially effective. Not reliable solution. Drones adapt. Frequencies change. Arms race continues. Small arms fire, rifles, machine guns, shotgun. Soldiers shooting at incoming drones. Sometimes works, mostly doesn't. FPV drones fly 80 and 120 kilometers, say. Hard to hit with rifles. And shooting reveals your position to enemy. Physical barriers, cage armor, slat armor, nets, adding protective cages around vehicles. Provides some protection against top attack, but reduces vehicle mobility, adds weight, obstructs crew visibility, creates new vulnerabilities, active protection systems trophy, iron fist, sophisticated systems detecting and intercepting incoming threats, work against missiles and RPGs, less effective against drones, detection systems not optimized for small drone signatures, and APS systems cost $300,000 to $500,000 per vehicle. Can't afford to retrofit entire force. Current state, no perfect defense exists. All countermeasures are partial. All are expensive relative to threat cost. All can be overwhelmed by quantity. Military forces are adapting tactics. Vehicles operate spread out. Minimize time in open terrain. Use concealment. Move only during windows of limited drone activity. This helps, but don't eliminate vulnerability. Fundamental problem, FPV drones are too cheap, too numerous, too simple to defend against completely. Defense costs more than offense. That's unsustainable. Which military system suffers most from FPV drone threat? A. Main battle tanks. B. Infantry fighting vehicles. C. Artillery systems. The answer reveals which military doctrines need complete overhaul. Keep watching July 2023 through February 2024. FPV drone warfare scales exponentially. Both sides produce tens of thousands monthly. Workshops in basements, small factories, volunteer assembly operations. The production is decentralized, difficult to target, difficult to disrupt. Ukrainian sources estimate 50,000, 100,000 FPV drones produced monthly across all small manufacturers. Russian sources claim similar production. Numbers are uncertain, but scale is clear. This is industrial production of disposable weapons. Target selection evolves. Early phase, early 2023. Operators target stationary vehicles, parked tanks, artillery pieces, supply trucks, high-value targets that don't move during attack. Success rate 60-80%. Intermediate phase, mid-2023. Operators target moving vehicles. Requires more skill. Predicting movement, leading target, adjusting for wind. Success rate 30-50%. Advanced phase, late 2023 present. Operators target moving vehicles in defended positions. Electronic warfare active. Defensive fire. Extreme skill required. Success rates 20-40%. But volume of attempts is so high that absolute number of kills increases. Operator skill becomes critical. Experienced FPV pilots are force multipliers. One skilled operator can achieve 5-10 vehicle kills per month. Amateur operators might achieve 1 to 2 kills per month. Training quality matters more than equipment quality. Both sides establish FPV pilot schools, training programs, simulators. The warfare creates demand for specialized skill set. Video game players, drone racing enthusiasts, anyone with hand-eye coordination and spatial awareness. The skills transfer. Cultural shift. Military forces traditionally value physical courage, close combat skills, ability to endure hardship. FPV operators sit kilometers behind lines. Safe, comfortable, playing what looks like video game, but their impact on battlefield rivals or exceeds frontline infantry. The nature of martial valor changes. January 2024. Documented case. Single Ukrainian FPV operator achieves 17 confirmed vehicle kills in 1 month. Tanks, APCs, artillery pieces. Each kill represents 1 to 5 million in destroyed equipment. One person, 1 month, 20-40 million in enemy losses. Using drones that cost maybe $8,000 total. The leverage is unprecedented in military history. No weapon system in history provided this return on investment at this scale. But there's a darker side. This is Iron Bullet, where we break down the battles that change wars. FPV drones don't only target vehicles, they target personnel. And the implications are disturbing. Conventional weapons have minimum economic threshold. Artillery shell costs $1,000, $5,000. Doesn't make economic sense to fire $5,000 shell at single soldier. Reserve artillery for high-value targets, groups, vehicles, structures. FPV kamikaze drone costs $500 and can target individuals, single soldiers, one person hiding in trench. The economics make it viable. Mid-2023 onwards, both sides use FPV drones for precision targeting of individual soldiers. Sniper-style warfare, but with explosive drone instead of bullet. Soldier in trench sees drone incoming, has 2 to 5 seconds to react, often insufficient time. Explosion, casualty, psychological impact. Soldiers report extreme stress from constant drone threat. Can't rest, can't relax. Drones can arrive anytime, from any direction. With minimal warning, the psychological warfare is brutal. Medieval warfare concept returns. Being outside fortifications is death sentence. Soldiers stay in trenches, under overhead cover. Movement between positions is dangerous. Movement in open is suicide. The Battlefield becomes network of covered positions with deadly space between, similar to trench warfare 1915-1918, but with drones instead of snipers and machine guns. Scale estimated 30,000, 50,000 soldiers killed or wounded by FPV drones on both sides through early 2024. Individual confirmed numbers are uncertain, but orders of magnitude are clear. This is a significant percentage of total casualties. The weapon that started as tank killer evolved into anti-personnel weapon, and the ethical implications are complex. Precision weapon reducing collateral damage, or making individual soldiers targetable by operators sitting in safety. Both are true. Counter tactics emerge, soldiers carry electronic jammers, personal systems, limited effectiveness but better than nothing. Soldiers watch sky constantly. Spotters, warnings, immediate cover when drone spotted, living underground, minimizing exposure. The battlefield adaptation is rapid, but adaptation has costs. Soldiers spend cognitive resources on drone threat, reduces effectiveness at primary missions. Sleep quality deteriorates, stress accumulates. Cumulative impact on combat effectiveness is significant but difficult to quantify. Future implications. If drones can hunt individuals cost effectively, what does that mean? For infantry, for urban warfare, for civilian areas? Questions are uncomfortable. Answers are unclear. How many armored vehicles have FPV drones destroyed total? Estimates vary wildly. Ukrainian sources claim 3,000 plus Russian vehicles. Russian sources claim 2,000 plus Ukrainian vehicles. Independent verification is difficult, but order of magnitude is clear. Thousands, possibly 30 to 40% of all armored vehicle losses in 2023 to 2024 period. Compared to cost, if 5,000 vehicles destroyed by FPV drones, average drone costs $600, average 5 drones per kill. Total expenditure, $15 million. Total value destroyed, 10-15 billion RO. Return on investment, 600 to 1,000.1. These numbers are approximate, but the ratios are striking regardless of exact figures. Let's answer the 3 questions now. How did hobby drone technology become the most cost-effective anti-armor weapon in modern warfare? Convergence of several factors. Technology maturity, FPV racing created commercial ecosystem. Cheap components, easy availability. Anyone can buy parts online. No export controls. No military procurement bureaucracy. Guidance advantage. Human operator with video feed is extremely effective guidance system. Better than early autonomous systems. More jam resistant than GPS. More flexible than pre-programmed systems. Humans excel at this type of task. Manufacturing scale. Commercial drone racing created supply chains, component manufacturers, battery producers, camera makers. Military adoption leverages existing commercial infrastructure. No need to build specialized military production. Cost structure. Disposable design means no need for reliability beyond single mission. Can use cheapest possible components. No redundancy. No quality control for longevity. Just needs to work for one flight. Training efficiency. Video game generation has transferable skills. Spatial reasoning. Hand-eye coordination. Stress management. Training time is weeks instead of months or years. Tactical flexibility. Small, quiet, launched from anywhere. Operated from safe distance. Hard to defend against. Easy to employ en masse. All tactical advantages. The combination made FPV drones inevitable. Once concept was proven, proliferation was unstoppable. Can armored vehicles survive in an environment where $500 drones hunt $5 million tanks? Current answer, barely, with modifications and tactics that reduce effectiveness. Future answer depends on countermeasures. Three scenarios. Scenario 1, offense, dominance continues. Countermeasures remain expensive and partially effective. Drone costs stay low. Armored vehicles become extremely vulnerable. Warfare shifts away from armor toward dispersed infantry with organic anti-armor capabilities. Armor's role in warfare declines dramatically. Scenario 2, defense catches up. Effective countermeasures are developed and become affordable. AI-powered point defense systems, directed energy weapons. Electronic warfare becomes comprehensive. Balance shifts back toward defense. Armor remains viable but requires protective systems that double or triple vehicle cost. Scenario 3, stalemate. Drone effectiveness and counter-drone effectiveness roughly balance. Neither side gains decisive advantage. Warfare becomes a mixture of drone attacks and defensive measures. Attritional, expensive for both offense and defense. Tanks survive but operate in highly constrained manner. Current trajectory suggests scenario 1 or 3. Scenario 2 requires technological breakthroughs that haven't occurred yet. But future is unpredictable. And the critical question, does the FPV drone revolution make traditional military hardware obsolete, or will countermeasures restore balance? Complex answer, some hardware becomes obsolete. Some adapts, some remains relevant in different role. Obsolete or severely compromised. Unprotected armored vehicles operating in open terrain, artillery systems without counter-drone protection, supply convoys without overhead